Hey, welcome everyone. This is Charlene of Angel Hack, the organizing team of the Hello Future Hackathons. We're excited to welcome you to our third workshop of Hedera Apex Hackathon, which officially kicked off on February 17th. We're now on day two of the hacking period, and we know many of you have your eyes on the prize, a share of 250,000 reward pool, and the opportunity to showcase your project to Hedera and its ecosystem partners. With such a significant prize pool and strong ecosystem support, it's no surprise that Apex has quickly become one of the most anticipated Hedera hackathons of 2026. We can't wait to see what you build. And this is just not about the prize, okay? This hackathon is backed by an incredible lineup of Apex partners, including AWS, Neuron, Hashgraph Online, Bonzo, and Hiero, who are all bringing their expertise and support to help you build something truly impactful. Now, without further ado, I'm excited to introduce tonight's speaker and mentor, Nadine from Hashgraph. She'll be laying a strong foundation on AWS with her session titled Enterprise Key Management for Hedera, signing with AWS KMS. Why this workshop? Nadine will walk you through the fundamentals of AWS KMS and how it integrates with Hedera. This session is especially valuable for those planning to compete for the AWS bounty, as it will equip you with the knowledge and practical insights needed to get started with confidence. A common question: can I participate only in AWS Bounty without joining the main tracks of Apex? Well, the answer is yes. You can focus solely on AWS Bounty if you like, but of course, you're also welcome to submit to the main tracks as well. AWS Bounty offers 8,000 in prizes, so it's a great opportunity for you to explore. Okay, for any questions and follow-up, please feel free to ask questions during the session by typing in the live thread. We'll address them later if time permits. And if your question comes later, that's completely fine. I'm going to give you a form here and you can give us your questions. Okay, there you go. Now, okay, I don't want to delay this. I'll hand things over to Nadine to kick off the workshop. Nadine, the stage is yours. Take it away.
Thank you so much, Sherilyn. Hi, everyone. I'm Nadine. I'm currently in Denver for ETH Denver. I don't know if anyone else is here. Really good conference so far. I'm talking today about HSM together on Hedera, super important topic. Just quickly about myself. I'm a developer advocate at Hedera Hashgraph. I've been with the company for now nearly 2 years. And before that, I actually was a cloud engineer. So before getting into the blockchain industry. So I've been working a lot with AWS. I have a solutions architecture diploma certificate, as well as a developer associate one. Should probably get recertified though in the next couple of months. I'm going to now share some slides. We're going to start with some theory. I'm going to try to keep this workshop super approachable. It's going to be a fully hands-on workshop, but just to start with a bit of theory to kind of set the scene. So please let me know if you can see my screen. Unfortunately, can't hear you because I can't see comments. So
yes.
Okay, perfect. Thank you so much. Okay, good. So again, we're speaking about KMS signing workshops. So signing on Hedera with an HSM without exposing your private keys. The problem here mostly is key management kind of is hard. If you develop an app, usually what you do is you save your private keys in an environment file. This is completely fine. That's normal for just spinning up a demo application. But if you want to go to production, that's usually not what you want to do. You want to have environment variables never in memory. We want to have them secure so they cannot be exposed. What can go wrong? You can accidentally commit environment variables to GitHub. There's actually a lot of exploits happening this way. There's a lot of scanners going around to different repositories to try to find these exposed credentials. Also, if they're not properly secured, they can leak and log in error messages. And if they're stolen, well, so usually it's your money and everything in your application. So we don't really want to get there if we're thinking of a productionized solution. Now, AWS KMS is a HSM, or a hardware security module. We use this for the secure key storage. The idea here is that if you have your private keys in an HSM like KMS, this private key actually will never leave that infrastructure. So you send the data to sign to the cloud, there it will be signed, and then it will be returned. So no one ever touches the actual private key. It's a lot of advantages, mostly that you can have an audit trail. So you can see there's this thing called Cloud Trail in AWS where you can log who actually had access to the key and what was used with it. It's easy to rotate them. And you can also fine-grain the policies. So actually, if you think of an entire department, you can have multiple people using, that same key with some different policy attached, like who can actually use it to sign, what exactly can be signed with it. So you can go very, very fine-grained. It's just way better than sending environment files around. And as we said, perfect for production, great for treasury management, and let's see how to actually implement it. How it works on a high level, and sorry, this is not the prettiest graphic, but it will do the trick. We have our app, and our app will create a transaction and hash it. Then we're going to send this to the cloud, to AWS KMS, and there we're going to sign the hash, and that's a SegP 256K1. And then we return the signature, and then, of course, we send it to the Hedera network to verify and execute. That's pretty much everything on a high level. We already have the code prepared. And just to quickly dive into that key, the magic, basically what's happening. So SegP 256 or 256K1 is an elliptic curve that is used for cryptographic signatures. So it's basically the same curve that is used in Bitcoin and Ethereum and many other blockchain, and Hedera supports it natively. So it kind of matters a lot in this workshop because there's a lot of different HSMs around. So AWS KMS is just one cloud HSM, but not all of them support this elliptic curve. So that makes AWS compatible with Hedera signing and therefore a great partner for this workshop. Now, I don't want to lose time because we have something to get through, and then we want to also take some questions in the end. So let's see what we're going to do in the next 45, probably a bit less minutes. We're going to set up AWS CLI. If you've never worked with it, it's a very straightforward process. It's super easy. Then we're going to create an IAM user with the permissions that you need. Now, an IAM user in AWS is basically just a user in AWS. You do not want to use your root for that, also security purposes. Then we're going to create a KMS key with this elliptic curve for signing. We're going to sign the Hedera transaction using that key. And of course, we're going to verify that everything worked and went through. So the end result is you're going to have an Hedera account whose private key only exists in a HSM. We're going to later go into the security benefits a bit more. Now I want to start straight away with this repository. Can you see my VS Code just to make sure that we are on the same page?
Yes.
Okay, perfect. So this is the AWS KMS workshop. And we're going to dive into exactly what we said we're going to learn. This is the same graphic that you have already seen. Now, let me copy this command into the chat.
Hey, Nadim, probably,
yes.
We are just looking for the security. Okay, you are sharing the screen again?
I need to find the chat to put in the... where is it? Join the chat. I can't seem to send comments, unfortunately. I'm not allowed to comment somehow. Okay, I'm so sorry for this.
You can send me a link to the private chat that is in the right, and I can copy and paste that for you.
I cannot do that, but let me do this on Slack in that case. So you can copy this for me. Apologies for this, because otherwise everyone has to copy and paste the links in. That would be highly annoying. So share screen again. That's the beauty about doing these workshops from conferences and not having your usual setup. So anyways, you should see now my VS Code. And this is the command you should run. So basically, there's an AWS KMS workshop repository, which you can find otherwise here on the Hedera dev GitHub repository. So I have provisioned this workshop repository specifically for this workshop. However, if you go on our docs.hedera.com and you look for sign Hedera transaction with AWS KMS, it is based on this documentation. So you can also follow this link and then have everything on a high level. But as soon as you are here on this workshop, you can, of course, git clone and then meet me here in the terminal. Now, the first thing that we want to do as soon as we have cloned this repository is to do an npm install. And after that, we can already think of configuring our Hedera credentials. Now, what you will have here is an environment sample file. So you need to put your Hedera account ID and your Hedera private key. The access key, the secret access key, and everything KMS related will come later in the workshop, so you don't have to worry about this at the moment. If you never have signed up for credentials, now is the time to do so. Go to portalhedera.com and then come back here. The way to put it in, just use the normal Hedera account ID. It doesn't have to be the EVM. Hexadecimal, and same with the private key. You can just use the DAR format. Next up is you want to install AWS CLI. Now, AWS CLI is a CLI that we will need to basically communicate with the cloud. Now, AWS has multiple ways to basically be able to communicate with you. Like you can, of course, log in through the console, which is online, which we're going to look into a second. But for the purpose of this, it's just so much quicker to provision resources on your CLI. So just do a brew install AWS CLI if you're on Mac OS and use Homebrew. Otherwise, if you don't want to use Homebrew, you can use the official installer and just copy and paste this command in your terminal. Or if you're on your Linux or on Windows, you can use these commands here. That's completely fine. It all will work the same way. And then what we want to do is just verify that this installation was successful. As you can see here in my terminal, if I run AWS -- version, I should see the version of my CLI and Python Darwin and some more things. So if this comes up, you're actually ready to get set. Nearly. What you of course need besides just the CLI is also some access. Now for this, we're actually going to quickly switch to the AWS console. Now, the AWS console, just for people who have never used it, let me quickly sign out. If you go to aws.amazon.com/console, this is the page that is going to greet you. So if you have never used AWS, you can go to create account. It will pop up this new window. It will ask you for your email address for root, an account name, and then you just can follow the setup steps. Now, I already have an account. So what I'm just going to do is to click sign in. I already see it's pre-filled with my account ID, my username, and my password. Now, I'm not signing in as root because of security reasons. So I have already set up a new user in AWS, gave it my own name, a new password, and also an MFA code just for additional security. I would really recommend always doing that, because in the end, AWS needs a credit card for you from you to be able to sign up. And if anyone gets your credentials and sign in, they can provision a multitude of resources that are going to cost you money. So we always want to be safe and secure in the cloud by making sure that no one can easily get access, especially to our root account. So now I'm logged in. If I'm logged in for the first time, this is how AWS is going to greet me. It's going to show me my deployed applications, currently 0 in this account. If I have recently visited something, it's going to show me that, and some other dashboards, which we're currently not looking into. Now, what we can do here is go to IAM, and we can see our users currently. So I have, for a personal project, a GitHub Actions user, and I have the Nadine user that I've set up for this workshop. What we can also see here is the overview of our account and, for example, security credentials, which we can then use to log in securely from our CLI. So if you haven't provisioned your security access credentials yet, you can log in, click to your username, scroll down to access keys, and then choose command line interface like we've seen here in the tutorial. So let's just quickly do this. I've already done it. You can go down and you see access keys here. You can click create access key, and then you click command line interface and click confirmation I understand, go to next. You can give it a description if you want, and then you can create access keys. It will give you this information just once. So if you lose your secret access key, you have to set up a new one. This is going to be your access key. This is going to be your secret access key. You can either download this as a CSV file or just quickly copy it here and then move on. So I've now set up a new credential, which I'm not going to use anymore, just to basically quickly show. Having done that, we now have to link the CLI or AWS CLI to the newly created credentials. How are we doing this? We are doing this by doing AWS configure in our terminal. It's now going to either ask me to give a new access key ID, which is the one that we just took from the cloud, or if I already have configured my credentials before, I can just click enter. I can click enter again, and then that is in. It will also ask me for a default region name. I'm going to use US East 1 as I'm currently in the States. If you're in Europe, you can use EU West 2 or anything else. It doesn't really matter so much. It has mostly to do just with latency. But for the sake of this tutorial, if you want to just quickly follow along with me, just do US East 1 and you should be set. And then as a default output format, we want to use JSON. So this is set, and I should be logged in. If I'm not sure if I'm logged in, I can run this command here, which is AWS SDS get caller identity. I'm pasting this in my terminal, and I click enter.
Sorry, we are not seeing your terminal, so there is any possibility if you stop sharing the screen, and once you share the screen, you click on entire screen instead of tape or instead of up top of or window, just entire screen, please.
Okay. Thank you for telling me. Again, I'm so sorry for this because I don't have an external screen. So as I'm at a conference, so I can only see it this way. Can you now see my terminal?
Yeah, it's perfect.
Okay, great. Let's just quickly go through this again. So I haven't lost anyone there. Have you seen the console before when I was on AWS? So did you see the AWS console when I logged in?
Yeah, IT community saw that. They don't show the terminal.
Okay, perfect. Amazing. So just go, we have time, so it's fine to go over it again. You will have to install the AWS CLI, which is step 3 that you can see here in the terminal. So either do it via Homebrew or via the macOS official installer, via Linux or via Windows. I have used Homebrew. However, you can use any of these. It's the same CLI. To make sure that you have it successfully installed, you can click AWS version, and you should see this in your terminal. You should see AWS CLI and then the version of your CLI. So next, again, we did this step. So we went to the AWS console and we configured our CLI. So we created security credentials. We then linked these with the AWS configure command to our terminal. So as soon as you have created those credentials, we can go to the terminal, do an AWS configure, and it will come up with this. And now, of course, this makes a lot more sense because you can see access key ID. I can click enter. I can say AWS secret access key, and I can put in there my secret access key, enter, and then put a default region name. So for me, that's US East 1. For you, that could be Europe. But if you want to follow along, it doesn't really matter. Just do this. Click through, chase an output, and that's it. So now we're hopefully all, again, at the same page. If I want to just double check, sanity check, that this has been successful, I can do AWS SDS get caller identity. And I should see this output, which I do. I should see my user ID. I should see my account. And I should see my ARN. Now, the ARN is basically just an identifier for any sort of resource in AWS. So for me, that's here my user. Everything is set up and we are ready to go. The next thing that we have to do is actually create a new user. Why is that? We just have signed up for AWS. Again, security reasons, as we have said before. If you are using your root user to create a key and then somehow someone gets access to your AWS account, of course, someone also has access to your entire, whatever you want to sign with Hedera. So for the safest way, we want to have a new user, which is called Hedera KMS user, which is just going to be used for signing. So I'm going to copy this command. I'm going to copy it into my terminal. And I'm already set up. So again, here we can double check our expected output, which is here Hedera KMS user, and it seems exactly correct. Of course, let's double check it in the console. So if you see my console now, hopefully again, so my AWS console, I can find here IAM, which is the manage access. Or if I star it, I also see it here in my bar. So I can just click on that. And now I see here in users, I have a new user named Hedera KMS user. If I click on this user, there's not so much in here yet because that user will need an access policy. Without having policies in AWS, you're not really allowed to do anything in the cloud. This is because of security. So we have, for everything that we want to do, we need to basically give it an allowance. Now here, when we add this policy, you should already find it in your repository here under Hedera KMS policy. We can see what it allows us to do. It allows us to sign. It allows us to get the public key, and it allows us to describe the key. And it allows that on any KMS resource. Now, it already is like only the thing that we need. Later on, if you want to be more secure, we could even point to our key and just say we are only allowed, this user is only allowed to use this key, which would make it even more secure. But let's attach this policy to our user. So the next step, I see I create the policy, point to the file here that I have created with the policy, and that has been successfully done. Now what I have to do, I have a user and I have a policy. I have to bring them together, so I have to link them. So AWS knows that they're matched. And I need to do this with this command here. So I first get my account ID from the same get caller identity command that we used before. And then I'm using an AWS IAM attach user policy command here. And that should have been successful. So if I go to my users and I look at my Hedera KMS user, I should see that policy being attached, and here it is. If you don't see it straight away, just click the refresh button. It sometimes takes a while. But I now see that this user has the signing policy it needs for KMS. Next, what we want to do is create the actual key, because so far we just have a user. We have a user with some rights, but we actually don't have a key yet. So what we're going to do is to move to step number 6, copy this entire command, which is setting our key with the exact elliptic curve that we need, setting also description, which is very optional, and then echoes or shows us our key ID. And that was successful. If I want to double check that this has happened, I can go here to K management service, or I can just put here KMS, it will come up. And then I now see here a key that is enabled. You see here a lot of different keys that are saying pending deletion. These are keys that I have used in the past, and then what the best way is, if you don't need them anymore, is to delete them. It will need 7 days though for them to get deleted, so they're actually queued up for deletion. We can't use them anymore, but they still hang around here. I know that this is my new key because it's the only one that is enabled. So this is the key that we are going to use for signing. What we want to do, we can either now copy this and paste it into our environment file, or we can be lazy and use the next bash command to do it. So if I now see here in my environment file, I should see my AWS KMS key ID, and these ones are going to come in a second. If you wonder why I don't have, like here in the sample, a Hedera account ID and a Hedera private key, that's not because I have set them, but I have set them in my shell environment file. So I might set as HRC file. So you won't see them here. However, if you normally follow along, you would just have it in your environment file. So again, we have a user, we have a policy, and we have the key. So we should be pretty ready to go. We just want to double check everything with this command so we can describe the key. Okay, it is there. It has everything that we need. It is of the elliptic curve that we want to have. So great. Now we can also check if the public key is accessible, just to be extra secure. And it is. It shows up in my terminal as well. Now, something that we can do optional is to create an alias for this key. Why would you want to do that? Mostly because it's easier to spot which key is yours. So I'm going to create an alias of this key and name it Hedera signing key. I paste this into the terminal, and here we go. So if I now go back to KMS and to my customer managed keys, I see that my key here has a name. This just makes life easier because usually in a productionized setting, you will have a multitude of keys, and it's kind of hard to know that 228D71 whatever is going to be used for this and that. So I would really highly recommend using aliases. And now what we have to do is create the access keys for that Hedera KMS user, which we are doing here. And now we finally have our whole environment setup complete. So I'm going to just copy that access key ID. And I'm going to put it here under my environment file. And then here, take the secret access key and put that in here. I have now everything that I will need to sign. So far, this has only been the setup. And this has not touched Hedera at all. This has just been the setup to create an AWS account, to do a secure role management, which can be used in a productionized setting, to deal with policies, and to actually create the keys. Now we are actually diving into what we're doing with the key, which is the coding part of the workshop. So if you see here my index.js file, you have here a pretty simple file, and it's just doing an HBAR transfer, actually. Let's quickly step through it. So we have here this main function that kind of like orchestrates everything. So we're going to start by creating the KMS signer. So if you go up here, we can see what we import. We're getting certain things here, like the KMS client, the sign command, and the public key command straight from the AWS SDK, or better the client KMS part of it. And then, of course, we take the account create transaction public key and everything else from the Hashgraph SDK. So what we're going to do here in this first line is to create that KMS signer, which comes straight from AWS. And then we're going to set up our operator client with our normal Hedera account ID and our private key. We will use this to create a new account. Again, separation of concern. This new account will then use the KMS public key. So we're going to do a normal account create transaction. We set the key, which is the public key from KMS. We're just going to set also some initial balance that this account can actually do a transaction. We're doing then a quick balance check to make sure that this was all successful. We're now then setting up our actual client, which we are going to sign with. Because on a very high level, the only thing that we're doing is, instead of having an execute and using our own private keys, we're using the KMS client and using that signer object from that client to actually sign our transaction. And then when we have that, we can transfer the HBAR, get the receipt, and check on Hashscan that everything worked well. So let's see if we can do that. We're just going to do an npm start and see if everything works. And I can see my KMS public key. I can see my new account ID, my balance, and a transfer status success. So this has worked, and it has signed it officially with KMS. Now, how do I know that this has been done with my AWS KMS key and not with my normal private keys, which are also hanging around in my environment file because I've set up a new account? Now, I can show you that by going on Hashscan. So this is here our transaction, and it's been successful. Great. And now I can go to this account here, and I can see here the key. I can first see it's the right key with the right key material. And I can copy this and go to compare texts and quickly remove the first two of the hex. What I can do now is I can take the public key straight from AWS with AWS KMS get public key and do some transformation magic because they're not in the exactly same format because it's compressed. Oops, sorry. Go here in my diff checker, put them next to each other, and click find difference. And I can see those two are identical. So I have officially used the AWS KMS key to sign this transaction. There's another way to double check this too, which is using CloudTrail. Now, CloudTrail is a way in AWS to see who accessed what at which time. It's also for an enterprise setup really important because you could always have like some bad actors also in your company, for example, to do stuff that they shouldn't, or someone like got access to your account, which is malicious and try to provision resources. So CloudTrail is really good to see what has happened in, well, you can go back ways. I'm going back 10 results just to get the newest one. And I can see, perfect, here at 8:35, here it's 8:37 now. So that adds up. We use the key to sign an event. So that was our transaction. I hope that's enough proof. It's really nice that it works this way. And as you can see in my environment file, I don't have any private key here hanging around that could have been used here in the index JS to sign this transaction. So this is a secure setup. To go over it quickly again, because we've done a lot in this workshop, especially setup-wise, but also now it's just to probably understand the concept. We have fetched the public key from KMS. We do that with a get public key command in the code, and we parsed it into hex and created the public key object. We create then a new Hedera account and fund that account with the KMS public key. We then set up a custom signer object, and that custom signer object is using the public key from the and the signer from the HSM, can't speak anymore. And then we sign the transaction. So we're using the signer function. We receive the bytes. We create the hash of the bytes. Then we send it to KMS. We receive the encoded signature. We parse it, and then we return the raw signature. You don't have to know this, of course, to participate in the hackathon, what exactly is happening under the hood. It's just here for reference if you're interested. And then having set up all of this, we can finally use this to execute our transfer. Of course, in this example, we are just doing a very simple HBAR transfer and we verify receipt, but you can use this setup for anything. So instead having a normal, usual setup that you know from creating demo applications or in the dev playground, you just follow this pattern and you can use this for any application. So for your workshop, so for your hackathon submission, it doesn't matter at all what application you create. You can be free, you can be creative, as long as it's using this pattern of using an HSM or a KMS key, basically, you are in the right path. Here again, to check over, you see all the different code snippets and what they are doing. So if you want to really deconstruct that, you can go into that and see. Really important to say is also there's probably maybe gonna be some troubleshooting. If you're following this workshop, it hopefully shouldn't. But what can happen if you do your own setup is that you maybe miss a policy. So this is the reason why we really looked into policies. Everything on AWS is designed to be least privilege access. So if you try to do something and you get back an error that says access denied exception, that means that you don't have the right policy attached to do whatever you want to do. If you have an invalid key spec, you used the wrong elliptic curve. It's really important to use the right one. It needs to be exactly this one, or it's not going to work. The transaction will be rejected. If your private keys aren't found, of course, you wouldn't have in the environment file or like me in your shell file. So you just have to make sure you configure that, go to Hedera portal, get your keys, and then you're ready to go. And also here, if it says ECDSA signature invalid, basically verify the KMS key type because something went wrong. Now, this was the whole workshop. However, in the end, if you don't use resources in AWS, it is always the best practice to clean up after yourself. Now, this setup shouldn't cost you money. So if you actually, just leave it up there, that should be fine. However, it's good to get into the practice of cleaning up because there might be one day where you provision a resource which costs money. So forgetting about that and then getting a bill at the end of the month is usually not the best way. So what we want to do is we want to schedule our key for deletion. So I'm going to copy this command in my terminal. And you can see here, the pending time window is 7 days. That's the minimum I can put. So I can't put 1 day, unfortunately. It needs to be 7 days. And if I now go back to Hedera KMS, here we go, customer managed keys. And I see now my key switched from enabled to pending deletion. And then next, what do we want to do? We also want to delete our alias. If we have created one, that's not going to be automatically deleted. And we probably want to use Hedera signing key again in the future. So we also deleted that one. I can again. Wait for this to happen. And then what next? We can do delete the IAM user access keys. So because they're not used anymore, I'm definitely going to do that because you saw my Hedera signer access keys on this terminal. So the best is to just make sure that they're gone. And they're gone. So I can now officially not use these keys anymore to sign anything or log in. I see here, finally, my alias here has also been deleted. So it's just nice to always double check that everything is really gone. Now, next, I can also detach, well, I have to detach the policy that I have created from the user. I cannot just delete the user without having detached the policy. That is not going to work. It's going to come back with an error that says, please first detach policy. So I'm going to post this in my terminal to having detached. Now I'm going to delete that policy that I have created. And that is gone. Sorry, I deleted all the version of the policies, and now I delete the actual policy. And now, finally, I can delete my user. Of course, if you're hacking for the workshop, you would not delete your user every day. You will keep it on for the entirety of the hackathon. And then later you can clean it up if you want. But just to show you how to do it. If I go back to IAM, and I go to users, I see the Hedera user is gone. I'm still there and my actions. And that's pretty much it. We have spun everything up. We have torn everything down and we have signed something in the middle. If you just want to have a quick reference and don't step through the entire explanation of this workshop, you can just scroll at the very bottom of workshop.md and you see the quick reference with all the commands that we used in this workshop. So the configure, the get caller identity to get your ID, then the user creation, so setting up either a user for just KMS signing or also just like I have the Nadine user, a user for access so you don't have to use root. Then we have the KMS key creation here, all the steps that you have to do. And then in the end, the verification. So if you just follow this and go one after another, the setup is actually really, really fast. That was it. In the end, you have the resources here. So the official documentation, as we have already said, you find that at docshedera.com. Just put some signing or AWS KMS in the search bar and you should find it. Then you have access to this repository with the workshop and your index file. And of course, you can have access to your own console as soon as you sign up. Good. So we have another couple of minutes. I hope that was, even though we had some issues with the screen sharing in the past, informative. I'm happy to take some questions if anyone has any.
Yes, thanks, Nadine. Thanks so much for that wonderful and insightful session. And I'm sure that our participants gained valuable knowledge on how to approach and build solutions for the AWS Bounty Challenge. And yes, we have questions. So first, two questions we have is, can you please share the repo link?
Again, the problem, I cannot share anything in the chat. It doesn't let me. I am sorry.
You can chat me on Slack and I can help you.
I don't know why I don't seem to have the access. I sent it to you on Slack.
All right.
Here, yeah, here, there you go.
Thanks,
So
Nadine.
apologies if you couldn't follow along.
All right, now I'm sharing it to you guys. Please check the live thread. Okay, that is the repo link that Nadine has shared. All right, next. All right, it is on the screen. What are the key benefits of using AWS KMS with Hedera?
Well, the key benefits are mostly like productionized solution, basically. So it depends if you how should I explain it? Imagine you have a team of developers and you are an institution or so, and you have like mission critical infrastructure where a lot of money is involved, and you have like one pair of a Hedera account ID and one private key, and that hangs in your environment file. Now imagine that you deploy this and somehow in like the logs, because it wasn't properly secured, or in a GitHub repository that that key appears, or someone from your team just takes the key and goes basically wreaks havoc, you basically lose everything. So you never want to be in that situation. So when we're thinking not having just a demo application, but having something that actually should survive in production, you always want to use actually an HSM to make sure that only certain people have access, that the key is secure, and that that key never leaves a secure infrastructure. That is the most benefit.
Thanks, Nadine. All right, we go to the second one. So this means other AWS services to interact with Hedera on our behalf, as long as those other services are allowed to access the AWS KMS service, like agents in the AWS Bedrock.
Or I was to interact on their behalf as long as the other services are allowed to access. I don't know if I understand the question exactly, because what we're doing here is just we're using the key to sign transactions. So you can use like any sort of application and then do a signing key. Now I wouldn't see why you would need in a Hedera application why any other service would interact with Hedera. So I might misunderstand the question, but you wouldn't have S3, for example, interacting straight away with Hedera, or like RDS or anything like that. So yeah, maybe reach out to me later and we can look into it. You find me on X as Nadine _ codes.
It's on Discord, right?
Or in Discord as well.
Yeah. All right. Okay. Yes. Please find Nadine on Discord, and to do that, you can scan this QR code that you can see on the screen. That will direct you to our hackathon. So after you register for the Apex hackathon, you will also be prompted to join Hedera Discord, and after that, you can find Nadine from there. Okay. Next, this is the last question, Nadine. Good morning. In a system doing lots of KMS sign and KMS decrypt, what throttling or rate limit patterns are commonly seen in production?
In general, whatever you set as the throttling or rate limit patterns, I would say. Do you think if you think about Hedera, and for example, if you use like a JSON RPC relay, of course, Hashio can throttle you. So we would say use your own JSON RPC relay. But in general, like there's no answer I can give to that as like a ballpark number.
All right, sure. Thank you so much for that. All right, guys, if you're interested in learning more about the AWS bounty and taking part, once again, be sure to join the Hedera Hello Future Apex Hackathon. Simply head to the bounty section and look for AWS to get started. And remember, you're absolutely welcome to participate in both the main track and any of the bounty challenges. So once again, please scan the QR code on the screen that you're seeing right now to be taken straight to the hackathon H. All right. So, okay, learning AWS plus Hedera is a lot to intake, right? But definitely Nadine has helped us understand it in the easiest way possible. So, if your question will come later, that is fine. So, once again, please join the hackathon. You will also be prompted to join the Hedera community on Discord, or I can also send you this link. Okay, no worry, guys. After I send you this link, I will contact Nadine and I will get answers from her so that you can have your detailed answer from the Hashgraph team as well. Okay, let me just see if we can still receive any questions. I think they're still digesting it, Nadine.
That's okay. Again, you can find me on Discord. You can ask questions there, as many as you want. I'm a mentor for the Hello Future Hackathon, of course. So, yeah, reach out. Happy to discuss. Happy to help debug.
Yes. Okay. So Catch Nadine is a mentor. Once again, as she mentioned, she is a mentor in the Hello Future Apex Hackathon. So please catch her as a mentor. So once again on Discord, and then she'll also be there during our AMAs and mentor office hours. So just follow us on Discord, and all the announcements will be there. Okay. Now I know that this could be it. And Nadine, would you want to give any closing remarks for our participants? We have 100K viewers, by the way.
Oh, wow. That's amazing. Closing remarks. Security is important. I feel like that's the reason why I love giving this workshop. I think it's a great opportunity also in the context of this hackathon to actually explore that concept. It will make you better developers. It will make you understand enterprise infrastructure so much more, which some of you are probably already very senior software engineers. Some of you probably be at the very start of your career. It's a very good skill if you know how to use HSMs, what is this, signing, policies, privilege, like having the least amount of access, and just cloud in general. So go for it. Hedera is great. This is just an additional skill on top, and combining them both, cherry on top.
I love it. Yes, that's true. But okay, before I let you go, guys, if you plan to tackle Hashgraph's online bounty, I would want to invite you and your team to join us on Monday, 23rd of February at 10 a.m. Eastern Time to listen and learn from Michael Kenter, the president of the Hashgraph Online. So please subscribe to Hedera's YouTube account to get the most updated workshops, not just for this hackathon, but there are also a lot more to be covered to ace being a developer on Hedera. I will leave the link here in this chat once again for anyone who are interested to watch Hashgraph Online Workshop on the 23rd of February. Okay, yeah, I just pasted it here. Right? Okay, that wraps up this session. We're all cheering for our Apex builders and hackers as you dive in and create breakthroughs. Remember, we've got back-to-back workshop, AMAs, and mentor office hours, all designed to give you the support you need throughout the hackathon. Keep showing up, keep building, and let's make an unforgettable mark on this Apex hackathon. Have a good one, everyone. Thank you, and goodbye.
Thank you. Bye.